Our lesson today is going to be on multiplying monomials. We're going to show the mental step and how we're going to use the commutative property. If you look up here, we have two monomials. We have 5x squared times 4x cubed. We can use the commutative property to group together things that we can multiply together. So when I look up here, I know that I can multiply the 5 times the 4 and group it together. And of course, 5 times 4 is 20. We can also group together like bases. And up here we have an x squared and an x cubed, so I know that I can multiply them together. And we have learned that when we are multiplying bases with exponents, this would be x times x. This would be x times x, 2 plus 3. We have learned that we just add the exponents. So this would be 20x to the 5th. Okay, in our next one, if you look, we can also use the commutative property to group together things that are alike. Up here we have a -3 and a -4. We can group those together. So -3 times 4. We can also group together like bases. So we have x cubed that we can multiply times x. And remember, when you have a variable without an exponent, that there is an invisible 1. So that's x to the first. And then we can group together y squared times y to the 5th. When we multiply each grouping together, we're going to get -12 x to the 4th, because we add our exponents, and y to the 7th. We added our exponents. Again, we can do the same thing. We can group together the things that we can multiply together. So we can group together the 3 times 6, and we can group together the x to the 3rd x squared, and you're going to get 18x to the 5th. If you look at this one, see if you can mentally look at it and find an answer. When I look up there, I know I'm going to go 2 times 5, which is 10. I'm going to go r squared, it's by itself, so I write down r squared. And I have t to the 1st times t to the 3rd, so I add the exponents, and that's t to the 4th. When we have a monomial times a binomial or trinomial or 4-term polynomial and so forth, we're going to use the distributive property. So when you see this monomial out here, which happens to be a constant 5, I know that I'm going to multiply 5 times the first term, which is 2x squared. I can do this mentally. I know that I can multiply 5 times 2, which is 10, and then I just have x squared. Then I'm going to multiply the 5 times the second term, which is x, and that results in just 5x. And then I'm going to multiply the 5 times the third term, which is 5 times 4, which results in 20. So my final answer is 10x squared minus 5x plus 20. Again, we have the distributive property, this time with a binomial. So I have the outside term, which is 2x squared y. I'm going to multiply it times the first term, which is 3x. I can multiply the 2 times 3, which is 6. X squared times x to the first is x cubed. And then I just have y. Notice I have a subtraction sign. That's like a -1. So in my next grouping, I have 2x squared y times a y, but it's negative. So that would be -2 x squared, and then we have y times y, which is y squared. So my answer would be 6x cubed y minus 2x squared y squared. Another practice, we have the term outside, 3ab multiplied times the first term, 5a squared. When multiplying that, we do 3 times 5, which is 15. We do a to the first times a to the second and add the exponents and get a cubed. And then we have times b. Then we're going to add and get the outside term multiplied times the b. We have plus 3a, and then we have to multiply b to the first, b to the first. We add the exponents and get b squared, our final result. Another practice, we have 5r cubed s squared times r. So all we have to do here is multiply the r terms together or add the exponents. So we get 5r to the fourth s squared. Then we have a minus sign, 5r cubed times s squared multiplied times 3s. I can do a negative 5 times 3, which is a negative 15. We have an r cubed. We have an s squared times s to the first, so we add the exponent and get s cubed. Here's how we can use this with geometry. This is actually on the back of your worksheet if you'll look at it. There's a couple of different ways that you could solve this and find the area of this irregular shape. The way I chose to do it was to break the irregular shape into 3 separate shapes that I could find the area. First, remember that to find the area of a rectangle, we multiply the base times the height. So if I break this first section, I can see that I have a 2x times an x. Multiplying x times x, we add the exponents, so that would result in 2x squared. My next box is x times x. X times x results in x squared. In the last box, I have 2x times 2x, and I got this number from the other side right here. So I have 2x times 2x, so I multiply the 2 times 2 and get 4, and the x times x and get x squared. So that box is 4x squared. Now all I have to do is simply add together the 3 rectangles. Well, one of them is a square. 2x squared plus x squared plus 4x squared. When adding with polynomials, we learn to look for like terms. All of these are x squared, so they're all like terms. And when I add them together, I get 7x squared as my final answer. This is also on the back of your worksheet as an example of how to figure out the area of a shaded irregular shape. If you think about what the first step would be, we first need to find the area of the large outer rectangle. To do that, we have to multiply the base times the width. We have a monomial and a binomial. So I'm going to put the monomial on the outside and the binomial on the inside and use the distributive property. So first I have 3x times 5x, which is 15x squared. Then I have 3x times 12, which is a negative 36x. So this is the area of the large rectangle. Now we need to subtract the areas that are not shaded. We have 4 boxes that are all the same size. One of those boxes right here, we'll just look at one of them. To figure out the area, we just have to go x times x plus 2. Again, we have a monomial times a binomial. So first we have x times x, which is x squared. Then we have x times 2, which is 2x. But we have 4 of these boxes. So now we need to take this binomial and multiply it times 4 to figure out what the area of all 4 squares would be. So when multiplying 4 times x squared, 4x squared. 4 times 2x is 8x. Now we want to subtract this polynomial from the area of the rectangle. We have learned that when subtracting polynomials, we're going to actually add the opposite. So we have to remember that we have to add, and we change each sign to the opposite. So this is going to become a negative. and this is going to become a negative. So when I combine this and subtract it over here, remember we're adding the opposite, so we're going to add it to it. I'm going to stack my like terms. So here's my negative 4x squared because I changed the sign because I'm subtracting. And I have a negative 8x. So I'm adding the opposite and the opposite. And that results in a 11x squared minus 44x. That is the area of the shaded region. It took several steps to get there, but you know all of the steps necessary to get there. And good luck on your assignment today.